Okay, as far as your syllabus is concerned, you have 3 standard locus that you have to know when it comes to your complex number. The first one is circle. Okay, to understand the meaning or behind this locus is that you need to understand what's the meaning of z minus a modulus is equals to r. So if you fall back onto your previous section dealing with the interpretation of z minus a, this is what it means in simple layman English is the distance of complex number z as measured from a. Okay, the distance of z from a. Then, if I put a number to it, okay, so what it means is that the distance of z from a must be a constant r. So if you look at it in the context of common sense, okay, imagine your point A. Give me a point that is distance r away from you. You actually generate a circle. Okay, that means this whatever that is, that point is always r distance away from you if you are point A. So you actually form a circle around you with you as the center of the circle. So with this is the first important concept, or the first locus that we are introducing to you. Z minus a modulus is equals to r basically represents a locus of point P, where P center of the circle is A with a radius of r. So one example to run you through. Okay, so if you look at this, z minus 1 minus I. So this one looks very close to what we have, z minus w. Okay, remember we must hit this form. Okay, so right here I need to modify it or readjust it and make it looks proper. Okay, so once I rewrite it in this form, what it means is that the distance of z from, okay, distance of z from 1 plus I must be equals to 2. Okay, so if you have this, you actually know that you are supposed to draw a circle, center at 1, 1 with a radius of 2. Got it? Next comes to this. Okay, so I need to do some adjustment again. I need to adjust it like this. So same thing, the interpretation will be the distance of z from minus 2 to I will be equals to 2 root 2. So you're going to generate a circle with center at minus 2, 2 and radius of 2 root 2. So once you have this, you can actually draw your circle out quite nicely. So coming back to the first one, okay, you're supposed to draw the circle, center at 1, 1, radius 2. So take note of what I have here, center 1, 1, radius 2. Okay, so a few things that you must always take note when you're trying to draw locus or loci in your complex number. There must always be equal scaling. Why you must have equal scaling? So that a circle looks like a circle. Okay, how many units represent one unit in the real axis must be equal to the scaling that you have set for your imaginary axis. Second thing, okay, please always use a protractor as well as a compass when you're dealing with drawing of complex numbers, okay, on an Argand diagram. So in this case, you are supposed to draw a circle. Please use a compass. Please do not use a tiny 50-cent coin. You cannot see the key features subsequently. Okay. Then a few things you must know is I've written here. Please check, okay, whether origin cuts the circle, or should origin be inside the circle, origin be outside of the circle. And for a circle, you surely must indicate where is the center and where is the radius of the circle. So very clearly I've indicated 1, 1. I've indicated 2 as the radius of the circle. Okay. Unlike your conventional curve sketching question, I do not label the x-axis or the x or y intercepts. Okay. So this will be your first circle that you're supposed to draw. Second one, same thing. After you adjust it into the so-called the standard form that we have, z minus w is equals to r, you again know where is the center of the circle. Okay, you know where's the center of the circle, and then accompany it with the radius. So again, reminder, draw with a compass. Okay, so coming back to the rest of the question, take note what does the question want. Okay, the question expects you to describe the locus and then give its Cartesian equation, and then for part 2 they ask for axial intercepts. So just now I mentioned you don't need to give axial intercepts unless otherwise specified by the question. So I have gone through with you how to do the sketch. Next I need to teach you how to describe. So you already know that it's a circle. Okay, you already know what is the center, what is the radius. So simply make the description. Okay, so locus is a circle with center 1, 1 and radius 2. This is your description. Okay. Then, if you know this, question asks for Cartesian equation. You need to fall back onto your secondary school knowledge. Okay, secondary school already teach you what's the standard equation of a circle. If the center is 1, 1, it's just x minus 1 square plus y minus 1 square. Radius 2, this thing will be your 2 square. This is your Cartesian equation. So similarly, you are able to do this thing. Okay, for the second equation, second part 2. Okay, but then part 2 asks for axial intercepts. So how are you going to do it? Okay, so the best way to handle this thing is technically use the Cartesian equation, because I know where's the center, right? The center of the circle is here. So fit it into your center of the standard equation of a circle. Substitute x equals to 0, substitute y equals to 0, you will be able to give me where is the so-called x, the real x and y intercepts. Alternatively, I can do it in complex number mode. So what to do is I activate this methodology. I'm going to let z equals to x plus iy. So when you substitute x plus iy into this equation, and while I'm trying to solve for the y-intercept, x must be 0. So instead of substituting x plus iy, I'm substituting 0 plus iy into this equation. Thereafter, you have this phenomenon coming up. The modulus of 2 plus y minus 2i is equal to 2 root 2. Meaning of modulus is that I need to square the real part, square the imaginary part, solve for your y. Then when I'm trying to solve for the x-intercept, I'm going to put y equals to 0, substitute your z by x plus 0i. Same thing, solve, and you will be able to get what you want. Okay, so that will be your second question, second part. Then of course, use your simple Pythagoras theorem to double confirm where is your position of the origin. Is it inside the circle, outside the circle, or on the circle? So in this case, if the center is minus 2, 2, the radius is supposed to be, what's the radius for this question? The radius is supposed to be 2 root 2. Via Pythagoras theorem, you realize that you actually hit the origin exactly. So, important thing is, if your circle is supposed to pass through the origin, you must show it on your paper, on your answer script, that it actually passes through the origin.